Hello, and welcome to our webinar, From Gray to Green, Green Stormwater Infrastructure, Complexities, Implementation, and Mythbusters. I want to thank you on behalf of AQUALIS and Stormwater Solutions for joining us today. We will be discussing a topic that is very relevant in our industry and provide insight into how to apply these solutions to your existing locations or municipalities. My name is Erin Zaske, Chief Development Officer at AQUALIS, the leading water management provider in the United States. My experience includes over 15 years of business and brand experience in the stormwater, construction, and manufacturing industries. In the closing of our session, I will share more about AQUALIS, but for a brief introduction, we're an environmental services company focusing on water management and support systems for stormwater and lift station assets throughout the United States and Puerto Rico. We provide comprehensive services from preventative inspections and maintenance to complete repairs, retrofits, and rehabilitations. We also provide complementary services such as underground pipe inspections, factor and jetting services, and engineering consultations. Our learning objectives for today include the following: exploring the many terms and trends in green infrastructure, including the benefits to the hydrologic cycle and treatment of both water quality and quantity. We will talk through terms including nature-based strategies, LIDs, and green stormwater infrastructure, or GSI. We will also myth-bust the common perceptions of roadblocks and obstacles to implementing GSI. This includes budgetary restrictions, contradictory incentives, and mysterious maintenance implications. We will be discussing maintenance protocols as well as some of the most prevalent green stormwater infrastructure. Additionally, we will showcase real-life case studies where GSI was instrumental in water treatment, how neglected GSI can hinder performance, and best practices to ensure your investment is protected. These case studies include newly developed green infrastructure and the maintenance challenges of ensuring the proper development and longevity of the system. Now that we've reviewed our learning objectives, let's get started. First, let's explore the terminology, trends, and benefits of the shift from gray to green stormwater infrastructure. In this next section, we're going to establish for this presentation what we define as green stormwater infrastructure. To better understand green stormwater infrastructure, it is important to note the differences between traditional gray stormwater infrastructure and green stormwater infrastructure. Gray stormwater systems were originally designed mostly to move stormwater away from buildings as quickly as possible. These manufactured systems are typically comprised of concrete or metal structures, including underground pipe and storm drains, helping to coin the term gray infrastructure. Green stormwater infrastructure, on the other hand, utilizes porous materials, including soil, vegetation, and permeable pavements to mimic the natural hydrologic cycle of a site. These systems are designed to capture the first flush of stormwater, which is often the most polluted runoff. By utilizing vegetation and natural processes, GSI offers ecosystem services including wildlife habitat, pollinator rest stops, groundwater recharge, biodiversity expansion, and more. This common use of greenery, including trees, grasses, and native vegetation, is what gives green stormwater infrastructure its name. However, not all GSI utilizes vegetation. Other terms for green stormwater infrastructure include low-impact development, or LIDs, or nature-based stormwater strategies, all terms interchangeable when referring to green stormwater infrastructure assets. What is green infrastructure? Green infrastructure, as defined by the EPA, is the water infrastructure, as defined by the EPA in the Water Infrastructure Improvement Act of 2019, focuses on three key components: storage, infiltration, and evapotranspiration. We are going to focus on these three components in the upcoming slides as the foundation of properly functioning GSI. While these definitions are evolving and changing, today's focus on this definition will explore GSI processes that bring both benefits and challenges to GSI stormwater management, including the implementation, maintenance, and functionality. While much of GSI is based on mimicking and taking advantage of natural processes, encouraging proper runoff collection and storage engineered elements of green stormwater infrastructure is essential to the process. This is especially important with GSI systems designed to capture what stormwater experts define as the first flush. This can vary based on municipal definition, but a good rule of thumb is the first inch of rainfall. Runoff is directed into storage facilities, commonly seen as dry wells, bioretention facilities, constructed wetlands, and rainwater harvesting systems. Storage components are designed to store large quantities of water during large rain events and slowly release water after storms. The use of vegetation is powerful within these storms. In fact, according to the Arbor Day Foundation, a single tree can absorb over 100 gallons of water. When professionals think about GSI, infiltration is often the first term that comes to mind, as this process is what typically sets green stormwater infrastructure apart from traditional gray infrastructure. Arguably, the most important aspect of green stormwater infrastructure is proper infiltration. After rain events, collected water slowly infiltrates into porous surfaces, including soil, vegetation, and permeable pavement, typically over a 48-hour period. This is done to reestablish the site's natural hydrologic cycle and more stormwater to soak into the ground and rain gardens, drain within 12 to 48 hours, especially important in the treatment and control of mosquitoes. Infiltration also increases water quality, allowing porous and permeable surfaces to act as a filter, removing pollutants. According to the Natural Resources Defense Council, bioswales can remove 90% of trace metals, oil and grease, 70% of sediment, and 30% of phosphorus. Unlike manufactured filtration processes, utilizing soils and vegetation does not require filter replacement and inspections. Groundwater recharge is another great benefit associated with GSI and is often a factor municipalities look for when considering sites for stormwater credit programs. Obviously, not all systems allow the groundwater recharge. Take green roofs, for example. Their location prevents any connection to allow groundwater recharge due to the location of assets. However, for systems that are designed to allow groundwater recharge, like bioswales, bioretention cells, and constructed wetlands, this provides both ecological and economic benefits through aquifer water management, utility expense reductions, and environmental stewardship. Infiltrated water is then converted back from the land to the atmosphere, allowing the water cycle to continue again. This transference can occur through both evaporation from the soil and other porous surfaces and from transpiration from plants. This process of evapotranspiration allows for natural, controlled release of water back into the environment. By allowing the water cycle to be completed entirely on-site, water falls and returns to the atmosphere at the same location. This minimizes the disruption to the local water cycle and reduces thermal pollution, often experienced as the heat island effect. The heat island effect is a phenomenon associated with urban development. Human impacts including construction of buildings, energy use, and disruption of local water cycles increase urban temperatures when compared to surrounding rural areas. In fact, according to the EPA, asphalt can run 20 degrees Celsius warmer than sod surfaces, increasing asphalt runoff by roughly 10 degrees Celsius. The cooling effect of evaporation combats the heat island effect and thermal pollution. GSI can be designed to support different scales of stormwater based on site-specific requirements. On the smallest end of the spectrum is the urban scale. These systems are engineered to help reduce stormwater runoff, but are not designed to capture large rain events. Typically used in, you guessed it, urban environments, these small-scale GSI manage part of the stormwater runoff and are often used in partnership with traditional gray infrastructure. Examples include rain barrels, city plantings, green alleyways, green roofs, and bioswales. At the mid-range and the most common size of GSI, the neighborhood scale allows for stormwater management on a slightly larger scale, capable of capturing the first flush of larger commercial complexes and even entire neighborhoods. Examples include bioretention facilities, rain gardens, and constructed wetlands. These systems generally require more space than urban-scale GSI solutions, but are capable of handling larger volumes of runoff. At the largest end of the spectrum is the landscape scale. This includes large natural spaces, riparian areas, the creation of parks, and forest preservation. While this size of system offers the greatest stormwater management capability, these efforts typically require implementation efforts at the municipal level. GSI in corporate and business spaces typically fall under the urban or neighborhood category. The basis of this presentation, the gray area of GSI, is not meant to diminish the benefits of GSI, but rather address the concern many property owners and regulators have in the implementation and management of this new water management strategy. While public attraction, and in many cases demand, for GSI is growing, there is no unified front for green infrastructure. GSI is still a relatively new stormwater management practice, and as in all aspects, it takes time for governmental regulations to catch up to the changing times. Therefore, there are a lot of unknowns, inconsistencies, and impatience involved in green infrastructure. It has been almost 50 years since the Clean Water Act was expanded in the 1970s, and still, changes are being made to traditional stormwater management regulations, so it can only be expected that regulations around this new stormwater management practice are going to continue, expand, and change at a rapid pace. That said, where we are right now, there is no standard, universal understanding of what qualifies green stormwater infrastructure. Incentives can vary drastically by region, state, and city, and currently, involvement is still largely voluntary. As an organization, we have seen the greatest adoption rates in areas that offer incentives, including stormwater credit programs. As these programs are adopted with local and regional municipalities, that trend will continue to grow. Despite the challenges, the trend toward green stormwater infrastructure expands beyond the United States. Globally, the GSI trend continues to grow. It is being used as a way to combat climate change, prepare for the changing climate, and of course, prevent urban flooding. This global dedication towards green stormwater infrastructure can be seen in the C40 Urban Nature Declaration, which was signed by over 30 global cities, including Austin, Barcelona, Berlin, London, LA, New Orleans, Paris, Seattle, and Tokyo, just to name a few. By signing, these cities have committed to developing greener and climate change resilient cities through the implementation of green and permeable spaces to support the goal of the Paris Agreement, limiting global heating to 1.5 degrees Celsius. This is a great step in the acceptance of GSI on a global scale, and we will continue to monitor the implementation of GSI in these cities as the forefront of the GSI movement. Sponge cities, which have been developed in Germany, India, and China, use an abundance of green infrastructure, allowing the city to mimic a natural forest ecosystem and absorb stormwater runoff to provide clean water, groundwater recharge, reduce flood risk, enrich biodiversity, and cool the heat island effect. Within the United States, the EPA has begun to embrace green stormwater infrastructure, providing resources for local governments, private developers, and other stakeholders to learn more about how to implement green infrastructure solutions within urban environments. We will now explore how U.S. cities and states have begun implementation. The global shift towards green stormwater infrastructure has been driven by the many benefits GSI offers at the corporate, community, and environmental levels. For corporations, GSI offers a reduced flood risk, reduced utility costs, including stormwater, energy, and water, from which we will dive into further along in the webinar, acceptance into stormwater credit programs, and drives community awareness and involvement with organizations. For communities, GSI provides aesthetic appeal and local beautification, has been proven to better community mental and physical health, makes green spaces more accessible, increases the appeal of communities for current and potential residents as well as tourists, and increases community education on relevant stormwater and climate issues. At the larger scale, GSI provides benefits including better water quality, better air quality, reduced pollution, including chemical and thermal pollution, increased biodiversity, provides pollinator habitats, helps recharge groundwater aquifers, and creates more climate change resilient ecosystems. We have begun seeing municipalities across the United States adopt these philosophies at a larger scale. Let us dive into some of the places at the forefront of the GSI movement. Philadelphia is a city with a combined sewer system, which has led the city to suffer from combined sewer overflows, or CSOs, throughout the city's existence. Back in 2011, the City of Philadelphia and the Philadelphia Water Department signed a 25-year agreement with the EPA to establish a comprehensive monitoring program to track and record their combined sewer overflows with an end goal of reducing CSO by 85%. Financial analysis estimated it would cost $9.6 billion if the city were to reach this goal through installing, expanding, and retrofitting gray infrastructure. Instead, they launched the Green City Clean Waters Initiative, which is expected to require 75% less funding to reach their goal. While improvements to existing infrastructure are still expected, the vast majority of stormwater management improvements will be met through implementing advanced green stormwater infrastructure throughout the city at the public and private levels. Portland is another city determined to adopt GSI. The city has implemented a variety of GSI programs, including the TREE program, which has a goal of planting 83,000 trees throughout the city, the Green Street program, which will construct over 900 green streets, which is the use of vegetation along the roadways or parts of medians, and Portland Eco Roofs program, which has planned 43 additional green roofs to be developed. Portland also received a $3.4 million grant from the EPA in 2002 to fund 30 low-impact GSI solutions as part of their innovative wet weather program. Milwaukee is often said to be the face of green stormwater infrastructure in the United States. These policies require all large developments to capture the first half-inch of rainfall using green infrastructure. The city prioritizes funding community-based green infrastructure to increase green space, accessibility, and community wellness. They have a green streets and stormwater management program similar to those found in Portland. And by the year 2035, Milwaukee hopes to capture 740 million gallons of water every storm by utilizing green stormwater infrastructure. At the state level, North Carolina recently drafted a stormwater action plan based around nature-based stormwater solutions, or green stormwater infrastructure. This education-based approach addresses the misconceptions of green stormwater infrastructure, encourages governments to lead by example in implementation of GSI, and is focused on increasing the education, outreach, and professional training for GSI and watershed management strategies. The state hopes to create a nature-based stormwater steering committee to ensure long-term support and progress and create an effective statewide watershed management that focuses on protecting, restoring, and mimicking the natural hydrologic cycle. In this next section, we're going to dive into the myths and common concerns associated with green stormwater infrastructure. We will break down some of the greatest perceived barriers to GSI and explore the truths based on our experiences as stormwater professionals. Investment costs. According to the EPA, many municipalities are reluctant to implement GSI due to the belief that GSI costs more than traditional infrastructure. While retrofits may have sizable upfront costs, incentives, reduced maintenance costs, and the use of free natural flood control actually increase ROI. Surface area sacrifice. It is commonly believed that GSI requires large, open spaces that are unable to be utilized for practical business processes, when in actuality, site-specific designs, including permeable pavement and green roofs, do not require additional surface area. Shorter lifespan. It is believed that GSI has a shorter lifespan than gray infrastructure. While it is true the average gray infrastructure can last upwards of 50 years, while green infrastructure is closer to 10, climate change has made gray infrastructure incapable of handling the increase in stormwater runoff due to the increase in frequency and intensity of storms. This has made the more adaptable and climate change resilient green infrastructure more beneficial for long-term stormwater management as water volume requirements continue to change. Maintenance requirements. Some are reluctant to adopt GSI simply due to the higher maintenance requirements. While the first few years after construction are instrumental in determining the success and do require a more rigorous maintenance program, as systems mature, they become more self-sufficient and can theoretically become self-regulating, requiring minimal to no maintenance. As briefly mentioned, funding is the greatest concern for property owners looking to install green stormwater infrastructure. To combat this, many municipalities have implemented stormwater credit programs that have become the most common incentive and main drivers for GSI adoption by private corporations. While these programs offer great benefits to property owners, they come with their own unique challenges as well. The first challenge comes from the regulations around GSI. Many stormwater credit programs are outlined based on what disqualifies systems rather than providing guidance to meet program qualifications. This can be confusing and discouraging for property owners, especially to those who attempt to complete the drawn-out process only to discover their systems do not qualify. Developed stores often find it difficult to qualify for stormwater credit programs as the rigorous standards can be challenging to meet by retrofitting already existing stormwater infrastructure. The last main challenge stems from the lack of universal standards. Because qualifications for stormwater credit programs vary between municipalities and variations can be significant, companies that have properties across municipal lines can implement the same GSI at each site. However, some systems may meet the local stormwater credit program and not others. That said, stormwater credit programs provide great benefits to property owners as well. Of course, those that qualify get the benefit of a substantial reduction in stormwater utility costs. In order to get qualified, many sites must work with certified stormwater professionals. This allows stormwater professionals to learn the intricacies of your system, allowing for a better understanding of maintenance, inspection, and potential repair requirements. Lastly, through stormwater credit programs, property owners get to build relationships with local regulatory bodies, ensuring all regulations are met and mitigating notices of violation. Another popular Another popular incentive is grants and other funding opportunities. But just like stormwater credit programs, grants come with their own set of benefits and challenges. First, many grant organizations require property owners to be proactive in reaching out or applying to receive funds. Unlike stormwater credit programs, which are relatively easy to find on governmental websites, finding potential grants requires research and outreach on the part of the property owner. If your GSI does receive grant funding, it may not be from a governmental organization. This adds another layer of challenges and steps to ensure all GSI meet local regulations. Lastly, grants and other forms of funding are typically just for the installation of GSI. They do not cover the continued maintenance costs associated with maintaining GSI. Grants do offer unique benefits. For example, there are a variety of organizations to partner with, including watersheds and environmental organizations. Grants can partially or entirely fund the construction of GSI, which can provide relief to property owners off-put by the high cost of implementation. Lastly, working with public and environmental organizations allows for publicity, stormwater education, and community involvement with your site. To better understand your site's ability to receive incentives, it is important to understand the main targeted issues that local municipalities are trying to combat through implementing an incentive program. There are 4 main targeted issues, and your city may be looking to combat either a single issue or a combination of these issues. Combined sewer outflow reduction. Some cities, including Philadelphia and Milwaukee, have a combined sewer system, one in which stormwater and wastewater use the same underground utilities. These systems are designed to overflow during large rain events to prevent the flooding of water treatment facilities. However, during these overflows, untreated wastewater is released into the environment, creating environmental and health safety concerns. Cities that experience CSO often incentivize GSI to reduce peak volume, reaching the combined sewer system and therefore reducing the frequency of CSO events. If this is a criteria for your stormwater credit program, GSI that offer plentiful storage should be considered. This includes cisterns, underground storage and reuse systems, and bioswales. Groundwater recharge. Aquifer recharge and recovery are a priority in areas that utilize the underground water supply faster than it can currently replenish. These municipalities prioritize GSI that allow for infiltration and groundwater recharge, like permeable pavement and sand filters. Water quality is another main concern for municipalities. For these locations, explore filtration-based GSI like constructed wetlands and bioretention cells or ponds that offer a natural filtration and pollution extraction process. Lastly, green space accessibility. Many municipalities see the benefits in GSI for beautification and aesthetics. To meet these goals, focus on vegetation-based GSI, such as riparian habitat and green roofs that offer local green spaces. Now that we have established what GSI is and the benefits that come with implementation, let's explore how to determine what GSI is right for your site and the maintenance requirements of 4 of the most common GSI systems. The first and one of the most prevalent GSI systems is bioretention cells. Bioretention cells are landscape depressions that capture and treat the first flush of runoff from surrounding impermeable surfaces and then dry out between storms. They are typically found in parking lots or along roadways. A site that is a good candidate for bioretention cells is one that allows for decent-sized surface area sacrifice for the development of bioretention cells, has permeable soils that allow for infiltration. The water table must be greater than 4 feet below the surface to allow proper function, and for sites whose goal it is to capture water runoff from the first flush. If looking to meet local stormwater credit requirements, these systems reduce combined sewer overflow, allow for groundwater recharge, increase water quality, and add green space. Bioretention cells require specific plant requirements, including plants that are flood and drought tolerant, as these systems pool water during storms and then dry out completely between events. Must have high vegetative diversity to minimize erosion, increase water filtration, and support absorption events. Non-aggressive root systems. This is especially important in clay soils, as some trees and shrubs with aggressive roots will intrude into underground pipes looking for air. Aesthetic appeal. Since these are found in parking lots and roadways, there is always a desire to make these systems aesthetically pleasing either to customers or communities. Preventative maintenance for bioretention cells typically comprises of hand weeding, trash removal, vegetation pruning, mulch replacement if displaced to prevent compaction to ensure the proper infiltration, supplemental planting, vegetation health assessment, infiltration testing, and sediment removal when needed. Rain gardens are comprised of a collection of native vegetation planted in a small depression designed to temporarily hold and slowly infiltrate stormwater runoff. Your site would be a good contender for a rain garden development if there's the ability to sacrifice a small area for the garden's construction. The soil is permeable to allow infiltration. It is a non-wooded site as water could damage roots of surrounding trees. There is a gentle to moderate slope. The site receives frequent small rain events, receives full to partial sun, and is in need of first flush capture, and is looking for water quality improvements. If you are looking to meet municipal goals to receive stormwater credit, rain gardens can help prevent CSO, allowing for groundwater recharge, increasing water quality, and adding green space. The requirements that make plant species viable for GSI differ based on the systems implemented. For rain gardens, plants used in the inner rings must be tolerant of high soil moisture with the outer ring and be able to survive both wet and dry conditions. Vegetation must also be relatively low maintenance, as accessibility, especially with high-powered machines, is limited to prevent soil compaction. Lastly, vegetation must be aesthetic to appeal to visitors. Standard maintenance requirements for rain gardens include hand weeding, trash removal, vegetative pruning, mulch replacement when needed to prevent soil compaction, supplemental planting if vegetation dies or becomes too spacious, vegetation health assessments, drainage testing, watering during dry spouts, and sediment removal when necessary. Green roofs are partially or fully covered with planted vegetation. Eligible sites do not need to sacrifice surface area, just roof space. Have a flat or low roof slope, no more than 30 degrees. Have strong structural support. Green roofs are heavier than traditional roofing. A standard green roof is about 20 pounds per square foot heavier after a rain event. The roof must receive minimal wind uplift. Like a standard roof, wind pressure may damage green roofs and potentially pull greenery off the roof. Require rainfall absorption. Green roofs do not collect surrounding impermeable surface runoff, but instead absorb rain that falls directly on the roof. For stormwater credit programs, green roofs reduce CSO, provide better water quality, and add green space. Plants on a green roof must be extremely weather tolerant, as roofs get especially hot during the summer day and exceptionally cold on winter nights. Drought tolerant. Green roofs do not contain much soil, allowing the entire soil substrate to dry out between infrequent rain events. Plants must have short root systems to prevent intrusive roots from damaging the roof or waterproofing elements. Plants can be intensive, more work to manage, or more like traditional garden, or extensive, natural, and less manicured growth. Maintenance on a green roof includes hand weeding, trash removal, drainage inspection and leak detection to prevent water damage, supplemental planting when necessary, vegetation health assessments, structural inspections of waterproofing elements and building integrity, and soil substrate inspection and evaluation for erosion and pH balance. The last GSI we will dive into are permeable pavement, a pavement alternative comprised of porous materials to allow stormwater runoff to be absorbed and held in subsurface stone reservoirs. Eligible sites do not need to sacrifice surface area, as permeable pavement is a traditional pavement alternative. Have a flat or low surface slope, have permeable soils to allow infiltration, require rainfall absorption. Permeable pavement is not recommended for surrounding impermeable surface runoff collection, as runoff increases changes to clogging, and are in need of groundwater recharge. Permeable pavement reduces CSO, recharges groundwater, and increases water quality. While not all permeable pavements have the capability to harbor plants, grid-style permeable pavements can be planted with grass. Maintenance is typically comprised of percolation testing, sediment removal through industrial vacuum services, replacement of joint aggregate, but all maintenance varies based on manufacturer recommendations, as we will discuss as we get into real-life case studies in the upcoming slides. While most deficiencies are avoidable with routine preventative maintenance by a stormwater professional, we do think it is important to address the most common deficiency concerns and how to address them within GSI systems. Mosquito control. As with all stormwater management systems, mosquito control is important. Within most GSI, apart from the constructed wetlands, standing water is often a sign of further issues such as compacted soil, improper infiltration, or drainage issues that need to be addressed. For systems like cisterns, they typically have screens on inflow and outflow ports to prevent mosquito reproduction. Erosion. If your system is experiencing erosion, retrofit the asset to include energy dissipation devices to reduce stormwater velocity upon entry into the GSI. GSI that have improper drainage are also prone to erosion. Improper drainage. Schedule an inspection with your stormwater management provider, but improper drainage is often caused by sediment accumulation, which must be removed. Invasive species. Routine maintenance will prevent invasive species from growing excessively within GSI through hand weeding and spot treatment. If your system is overrun with invasive species, further corrective action and possible repairs may be required. Compacted soil. Compacted soil is often a sign that the original construction was not completed properly, typically impacted by the use of heavy equipment. If this is the case, the soil substrate will need to be replaced and reinstalled using the appropriate construction methods to prevent soil compaction. When green infrastructure is part of a preventative maintenance plan, all of these deficiencies can be closely monitored, especially during the first year after construction. Now, let us explore some real-world examples of GSI maintenance, taking all of the components we have discussed so far and applying them to specific sites. In our first case study, we're looking at a multi-site client that has a preventative maintenance plan with AQUALIS. We have been routinely monitoring this location and the infiltration rate of their permeable pavement. This location has two types of permeable pavement. Each requires maintenance recommendations per the manufacturer. One requires a more intense maintenance approach. This type of permeable pavement includes joint aggregate and can be seen here in the pictures to the right. This pavement is located in a high traffic area. Per the manufacturer's recommendations, this type of pavement requires monthly visual inspections including breaking up of the crusted material that may be covering the joint aggregate material and preventing infiltration, and targeted industrial vacuuming when percolation testing determines a site needs cleaning. Percolation tests include a simple frame that is filled with water and time to assess percolation or infiltration rates. Analysis includes that an infiltration rate 30 seconds or under is exceptional and does not require maintenance. Once infiltration rates reach 90 to 300 seconds, action is required. The second permeable pavement at this location is designed with larger spacing between the permeable brick and does not include aggregate material. Due to the location of this site in the Midwest, biannual maintenance, including sweeping and aggregate replacement, is applicable to prepare for and repair from winter to prevent clogging, especially from snowmelt, de-icing sediment, and general compaction. Use of a protective blade is important on a snowplow to prevent damage to the assets, as well as salt should never be used on permeable pavement as it erodes the aggregate material and adds to the sediment collection. As a reminder, it is essential you are aware of manufacturer requirements and partner with stormwater professionals to maintain these systems properly. This next site is located in Lake Forest, Illinois, and includes multiple green infrastructure assets on site. AQUALIS has a routine preventative maintenance agreement with this client to monitor growth, reseed, and provide corrective maintenance when necessary. Here you can see that a nuisance species has taken root among the planned vegetation. Regular inspection for and removal of nuisance species is vital in ensuring the health of green roofs. Nuisance vegetation can quickly overtake, reducing the infiltration of the native plants intended to embrace the hydrologic cycle and reduce pooling of water. It is important to have trained stormwater professionals maintain these systems, as well as intended landscapers and property managers may end up damaging green roofs by allowing unintended species growing within these delicate systems. Without removal, invasive and nuisance species can consume the area and limit function. Just because it is green doesn't mean it's helpful. While the presence of unplanned species is inevitable, hand removal and spot treatment by stormwater professionals mitigates the threats posed by weeds. Once nuisance species are removed, it is important to inspect the buried assets to ensure intrusive roots or other damages did not occur. This is another great example of nuisance species. This site is located in Cottage Grove, Minnesota, and is part of a multi-site preventative management program. This site is maintained to ensure proper functionality and growth of the native vegetation. The location of this invasive species seen here in the photo was located in the rain garden. This rain garden was impacted by both Canada thistle and Salus thistle, which had to be hand-picked and spot treated. Mulch also had to be redistributed and supplemented to reduce soil compaction. It is also important to monitor ground level systems in cool climates throughout the winter to ensure snow is not being stored on top of systems. If snow is piled onto GSI, it can lead to clogs, soil compression, and blocks rainfall from entering systems while snow is present. Here we see a new system that requires extensive monitoring to ensure the proper establishment of plant growth, as well as the proper monitoring of compaction, sediment collection, and overall functionality. Since these systems are delicate in nature, properly applying intensive maintenance in the first few years will secure this site for success. As the system matures, one can begin to reduce frequency of maintenance when growth is established and infiltration is monitored so that the system becomes almost self-sufficient on its own with minimal maintenance, oftentimes quarterly, to remove trash and replanting when needed. This site has a newly implemented rain garden, and AQUALIS was hired to provide post-construction maintenance. Maintaining systems at this stage determines the fate of your system. If vegetation is not able to fully establish, it may die off and the system will fail. In this case, the site was receiving increased heavy sediment accumulation that must be manually removed, and evaluated. As we continue to monitor the site, it may be warranted by the original designer and construction to address due to either a construction malfunction or design issue that is causing the increased sediment to accumulate. Again, establishing maintenance and monitoring post-construction ensures the investment into green stormwater infrastructure increases ROI, reduces property flooding, and ensures system functionality. What action can you take? First, research your local GSI regulations and incentive programs to determine if GSI is right for your city or site. Educate and spread awareness regarding GSI best practices, including providing the appropriate arguments to those common myths and barriers we spoke about earlier in the presentation. If you have GSI on your property, establish proactive routine maintenance inspections with a green stormwater maintenance professional to protect your investment and encourage the proper storage, infiltration, and embrace the site's evapotranspiration. And lastly, installing, retrofitting, and repairing your site with GSI to optimize function, increase your site's aesthetics, and embrace the future of the next generation of stormwater assets. As we close our formal presentation, I want to share a bit more information about the AQUALIS difference and how we assist property owners, municipalities, and regulators across the nation in providing stormwater management. AQUALIS is the leading nationwide provider of stormwater and lift station management services. These services include preventative maintenance, corrective maintenance or repairs, retrofit and redesign, as well as emergency response. AQUALIS helps protect your assets, mitigating notices of violation of stormwater control measures, diminishing flooding risks, and supporting your efforts in environmental stewardship. We partner with retail, commercial, industrial, municipal, healthcare, hospitality, educational, and governmental industries. We service single-site and multi-site organizations through our preventative maintenance programs. With more than 20 years of experience in the water resource industry, AQUALIS provides innovative and leading-edge solutions to meet budget constraints and exceed compliance expectations. With programs that ensure quality, like our Quality Assurance Program, we strive to deliver an exceptional client and raving fan experience. As the leader in stormwater and lift station management, we are pleased to partner with and educate property owners on the importance of preventative maintenance and water compliance. With AQUALIS preventative maintenance programs, we can help building owners and facility managers avoid costly violations, reduce liability, improve system performance, and increase overall property safety. We are a team that prides ourselves in safety, compliance, and education. Our teams are highly specialized in their fields, from stormwater inspectors to certified small space training. Our certifications include state-level certificates, where applicable, as well as product-specific certifications to properly install and manage these stormwater assets. Many of these certifications include routine continuing education for renewal to ensure that we are following the most up-to-date regulations and processes. If you are interested in learning more about the AQUALIS difference and partnering with a stormwater management or lift station provider, you can reach out to us directly on our website at aqualisco.com. I appreciate your time today as we end our formal presentation and move into the Q&A portion of our presentation with our Vice President of Enterprise Account Management, Jeff Urban.
Good day, everyone. Thanks, Erin. Very well done. I think we're just going to jump into a couple of questions that we had. And one of those questions was, how do you prevent mosquitoes in some of these systems? And Erin, you touched on that briefly, but regarding any systems that are designed to trap water and hold it, like cisterns or systems like that, there are methods that we can use, basically covers, screens and things to prevent the bugs from getting in there and laying the eggs. Regarding the green infrastructure specifically, rain gardens, bioretention cells, items like those things, these are not designed to hold water for a very long time. Again, Erin, you touched on it, typically 24 to 48 hours. Those systems should drain out. If we get into a situation where there's standing stagnant water and it's good breeding grounds for mosquitoes, it's really the remedy to that is to check out the asset as a whole and make sure it's infiltrating as it should. I know we can get into things like wetlands and stuff that may have that standing stagnant water there for a while, and there are some treatments that we can or a stormwater professional could apply to make sure we get those mosquitoes taken care of or reduce them as much as we should. Good. Another question we had, what happens when green stormwater infrastructure reaches the end of life? All depends on the system, but I know it generally involves, especially with the systems that involve a lot of plantings and things, replanting that mature vegetation. One thing about a lot of stormwater systems, they do have a life cycle. Some of the green infrastructure, as good as it is for the environment and all the benefits we spoke about today, they do have probably a little bit shorter life cycle than some of the traditional hard assets like traditional catch basins and ponds and things like that. So when the vegetation does reach a super mature state, it is good to replenish and replant some of that. Turning over the soil substrate is a good method to make sure it's infiltrating as it should, and really just reevaluating and keeping an eye on those infiltration rates just to make sure that water is getting down into the ground as it should would be a good way to check on those things and make sure we extend the life of these assets. I know another question that I saw, Paul, I know you mentioned permeable pavement. Why is it, why is it kind of pushed when, nobody maintains it properly? Very good question, a very good point. I think that can be said for a lot of different stormwater assets. The truth is when these systems are installed on your property, a lot of them are going to have operation and maintenance agreements with the municipality or the city, and it is up to the owners. It is the owner's responsibility to maintain these systems. Some are more hands-on than others, including permeable pavement. So you make a very valid point there. But if going that route, it's just very important for the ownership to realize that not only is there an installation cost and things, but there's also a life cycle cost that you got to take into consideration as well, and get the properly trained stormwater professionals on site to make sure these systems are being taken care of. Looking at other, what is the best way or a good place to start when researching local GSI regulations and incentive programs? Very good question. I'd start with the local watershed or municipality districts. They'll typically have a stormwater or, again, the watershed district for your particular area would be a good place to start. Talk to somebody there about what they offer. What are the rules and regulations? Every, local municipality is different. Just how the EPA is written, the Clean Water Act, it's onto the local jurisdictions to kind of enforce that. So there is a lot of intricacies as you go around the countries. Typically, a lot more rules and regulations and closely monitored situations when you get into the sensitive watershed districts around the coast, Pacific Northwest, Florida, the Northeast. And so it's something to keep an eye on. But I would definitely start with either your local municipality or the local water management district, and they should be able to point you in the right direction. Just checking through. Question, how do you moderate green stormwater infrastructure from very wet tropical areas like here in Baton Rouge to more arid areas? there are certain things that would that are more particular for I guess certain climates. I've had a lot of experience in Arizona. There's not very many rain gardens in Arizona. I can't even think of one that in all my experience in the stormwater industry. And it's not a very good place, obviously, to have one. And so I think as you think about green infrastructure and the climatology and what's normal in your area, I do know these systems are designed for certain climates. In an area when Baton Rouge maybe gets a lot of rain, making sure that these types of these systems can handle that water load. I know we've done some work down in Florida with permeable pavers, not the traditional ones that you saw in this particular presentation, a little bit different model that it's basically a lot of sand and some the permeable pavers go in there. It's not like the hard asset. The one you saw today was in Michigan, where that snow and ice can get in there. So definitely these types of green infrastructure are designed for certain climates, and definitely getting with a local engineer if you're interested in doing it. They would make the proper recommendations. But a very good question and a very good point there. I think that's about it as far as the Q&A. I'm going to turn it back over to the administrator. And again, Erin, I thought you did a very nice job, and appreciate everybody tuning in today. And we'll go from there.
Thank you so much, Jeff and Erin. This is Katie Johns, Managing Editor of Stormwater Solutions. On behalf of everyone today and AQUALIS, I want to thank everyone for their participation and for staying engaged with us. This webinar will soon be archived at the same URL you used today and on estormwater.com, and it can be viewed on demand, so feel free to share it with others. Additionally, we'll send an email in the next 24 hours with the recording. So long, everyone. Stay informed, stay well, and thanks for tuning in.